Hello. A lot of things I cover in this update. I've changed the suspension on the cart. Only on the new cart, and I'm going to do it on the old cart, but it's a significant performance upgrade. Also, I talk about some decorations for the new cart, and I kind of want your help. I've given you 9 selections. Please let me know which ones you like best. I also have the idea to do maybe a David Pumpkins mural on the back, and then the side of the cart will say any questions. Those of you who know David Pumpkins will get that. I also talk about some mundane stuff like putting Loctite on screws or ensuring I have the correct polarity. Well, some of these control boards are expensive, and if you put the wrong polarity on them, you'll damage them. So that's important. Loctite on screws is also important because there's a lot of moving parts that vibrate throughout the entire run. And I don't want this coming apart, going off track. It could be a safety issue more than a malfunction. So it's important enough that I decided to talk about it. Couple things I'm going to be working on in this update. I'm pretty excited about this part right here. This is an aluminum coupler bored to 8 millimeters on one side and 6 millimeters on the other, and each side has a set of set screws. My optical encoder, this is what's going to measure the rotation of the motor, has a 6 millimeter shaft, so that'll fit on snug and I can screw it down. This 8 millimeter opening on the shaft of the motor here, and then bring the optical encoder and screw that down right there. As this motor's turning, that transfers the motion to this optical encoder, which will be wired up to this speed control board by Pololu. Something else I'm going to be working on, I built these cables last weekend, and they are simply the ends of the cables were looped around a pencil and then soldered to create loops to go on these metal tabs, and then I painted the ends so I could remember which is which. But they'd have to be unbolted to take the batteries off. So over this week I built a battery harness which gives me proper lugs for each battery. Since I have two 12-volt batteries, I wired these in series to give me 24 volts out, and this is what I'm going to connect through to the drive circuit. Also, in line with this are quick disconnect connectors. Both batteries have the same polarity, and they match the connectors on the harness that will be attached to the cart. And what this does is ensures, regardless of which battery I plug where, proper polarity will be maintained, and it will give me 24 volts out. Once all that's done, I'm going to work on programming the settings in the Pololu to match as close as I can the old cart. I am also going to wire up a wireless relay so I can stop and start this cart with the same key fobs that the old cart is, and then all the buttons will be programmed to the same frequency set. See you guys in a few. And I'm back. So what have I done today? I have added the new battery cables, these red and black cables here, and the length on these is there so I can pull a battery, set it down, and then using the quick disconnect my battery. Up here you can see I've added the wireless module. This has 2 relays in it. One triggers the stop and one triggers the go. With the stop button, I tied it into the safety relay, so if I hold this button it turns on the strobes. It's to prevent somebody else from dispatching it with the wireless remote. I have mounted the frequency feedback here. I'm going to move the wheels just a little bit. You can see it turning in there. Added these braces, which I said I was going to do 2 videos ago. I've done a lot of programming to get this cart operating in the same fashion as the old cart. Okay, I'm sitting on the new cart and I've got the old cart parked over there. So both carts are wired into the same remotes. So I'm going to hit go and I start going, and you can see the other cart is also going. So I've tried to get these guys to run at about the same speed. And so I want to show you that as the cart comes around. I'm going to dispatch now. And then that one's going to park on the stop bar. As goofy as it is, I've been sitting here going in a circle just trying to get the carts aligned. So now I think I'm going to try to let the cart get close, and I'm going to override the stop bar to see how close that cart gets. We might have a collision. Oh no! Oops. So both carts are just steering themselves, following the line. I haven't made any speed adjustments during this whole video. They'll never follow this close to each other. So I'm going to let that one park. Oh, slight collision. So the old cart is just a hair faster. I've added some Loctite to the set screws on the couplers because I don't want that coming undone. And I've also, on the screw that holds the control arm on the wiper motor, have added Loctite to that. Something that's happened on the old cart, just from the constant back and forth, loosened up that screw a little bit, and I was noticing some, I guess some sloppy behavior. It was still tracking, but it didn't seem to be responding as fast, and that's because the control arm had dropped a little and had a little bit of play. So pulled those apart, added Loctite, and tightened it back up. This is the front of the old cart. The new cart is going to have a different front board. It's going to be a little more rounded, maybe look like a tombstone, but instead of this guy, the new cart is going to have something a bit different. I took one of those large plastic pumpkins and cut it in half. So it does stick out a bit further than the other cart. Now for the backboard, I've cut out my piece of wood to the overall dimensions. It's not going to be rectangular, and this bit of black plastic there represents where the bench will be coming out, so you won't see anything that's there. And the reason I did this is I am projecting different skulls that I may want to trace onto the backboard, and I'll cut the top of it to match whichever silhouette I end up using. So what I'm going to do is include each of the skulls with a number, and you guys can help me figure out which to do. At least vote on your favorite. I can't decide which one I like best, so I'll attach those here shortly. Okay, this is number 1. I'm going to put a number in the bottom corner with some tape. Now keep in mind, even though there's no light on the bottom of the board right here, that board is still going to be present. So the board is cut to the overall dimensions. So just because there's no light projecting on it doesn't mean it's getting cut away. So this is number 1. I'm going to go through each one with a little taped off number right here in the corner. Number 2. Number 3. Number 4, keeping in mind that anything in the black area down here will not be seen. Number 5. Number 6. Now in this one, I am going to not have this sword detail. It'll just be the clean arc. And number 7. And number 8. And number 9. There's one more thing I wanted to talk about, and that's the way the sub-chassis is hinged to the frame. Right now, it's just got a set of straight hinges all the way across. That's these brass plates here, and that allows the wheels to move up and down, kind of like a hinge. So let's say the wheels are attached on this board here. So as a cart moves along and the ground changes unevenly, it can hinge up and down to make up for differences in height. And since we're going to try to add a ramp to this, they definitely need to have all 3 sets of wheels contact the ground. And the only way to do that is to move one of the sets. Here's the problem though. As the cart's moving, the wheels can move up and down this way, but if one edge of the ground raises and the other one doesn't, it's going to lift both wheels because there's no side-to-side movement. So I found some of these. These are left over from building the first cart when I was trying to get the front wheels to steer like a car. I think it's called Ackerman steering. This was to make up for any slop in my linkages. But I abandoned that because the angles were just too complex, and I never found a suitable linkage geometry. So I had these left over, and here's my thought. I'm going to bolt these to the main frame, and then I'm going to make a bracket off of the motor frame and bolt that through the bracket. And so that will still allow the wheels to still move up and down as needed. But if one wheel is slightly higher than the other, it'll allow some play as well as still pivoting this way. And again, that's only because we're going to go up and down a ramp, and if we approach the ramp at an angle, one side's going to have to come up first. So that's what I'm going to be working on today. Hopefully I'll come up with something. So here under the cart, I have bolted the connector to the main frame of the cart. This bottom frame is the movable frame that has the motors mounted to it. So this is drilled through and bolted from behind. Well, this will be the connection point that attaches the subframe. I'm going to have to build a bracket off of this and up. It will allow rotation in this direction to allow the wheels to swing up and down, and then from the front it'll allow the sub chassis to have some movement. So in order to achieve that, this chassis can't be this close to the frame. I'm going to have to drop it a little bit. That will give the ends some room to move up and down. Something else that I forgot to mention earlier, this piece will have some left and right wobble, and I don't want that. I only want this direction of movement. So to eliminate this, I'm going to have some kind of brace right here that just comes down, and it's like a bumper, I guess, to keep the back of this chassis from swinging this way. So I'll have a brace on either side. I'm gonna have to try to capture the frame so the back of the wheels, if they try to torque out left or right, this will capture it from either side and just allow it to move up and down or this way, because I don't need any of this movement. Cutting bits of metal that will become the hinge piece for the new joint. The bracing that's going to keep the sub chassis, the motor chassis, from drifting in the background is also kind of going to be a safety feature. It's going to capture it from inside the frame, so if that front joint breaks, comes loose, or malfunctions in any way, the motor chassis is still going to be held in place by the two posts that are going down from inside the chassis. It's very unlikely, but I want to have it there as a backup just in case. Okay, now it's time for welding. Yay! I've laid out some gloves and cardboard to help deflect any of the slag, because I am unable to take this apart the way I want to. And there's the obligatory weld in this video. I've got the front forks welded in place. So this is what it looks like. There's my holes for bolting right here. So now I'm going to try assembling it. Tight fit. To the grinder. Should have ground more away. Okay, ground just a little bit more metal away, but I'm also going to try this. I've tapered the front of the bolt, so hopefully the small end can line up, but then the taper will help shift everything I need in the right direction. Look at that. Nice. That'll hold it in place while I go and try to find another bolt. But it gives me actually, that's not the motion I want. I want this motion. So let's lift this up a bit. So there we go. Now I've got this motion and this motion. So I want to reduce this motion by adding brackets to the back. While still having this motion. Back here, I've welded in these pieces here and here. And as you can see, they're inside this subframe, which is this piece here. So if that front joint breaks, the motors want to pull the frame that way, it'll still grab the back of these pieces. And it can probably still drive the cart. It's not really something I want to test, but I bet it could. So coming back over here, I've put the gas lifter back in place. So the cart the wheels could collapse all the way down to there and come all the way up to here. And while it's running, you can see I can shift side to side. That was my goal right there. Mostly they'll run right here in this middle range. Flip it over, put the batteries back in, see how it behaves. Alright, here's a total case of me amusing myself. As you can see, I could rock the cart back and forth just by the lifter lifting up against the wheels. The drive wheels still maintain connection to the ground. I'm not worried about the cart tilting. I'm actually worried about the middle drive wheels tilting. So the cart should never actually tilt like this, but if one of the wheels needs to go up or down over the ramp sideways or at a diagonal, it can. Thanks for watching.